Okay, today in class you actually worked with your groups to do a bunch of adding and subtracting of rational expressions. This is just a quick video to review the things that you should have discussed in your group, and I'll give you some examples of how I would add and subtract. So, number one, in order to be able to add and subtract fractions, you've got to have common denominators. If you do have common denominators, check for subtraction. Remember to distribute your negative to all the terms in the numerator. Then go ahead and add and subtract in your numerator, which would be combining like terms, and keep your denominator. This is what you used to do in 3rd and 4th grade when you learned to add and subtract fractions. If you do a check for common denominators and the answer is no, then you'll have to factor your denominators to find the LCD, multiply the numerator and the denominator by whatever factors it might be missing, and then continue with the add and subtract process. Remember, once you find the common denominator, keep the common denominator, only add and subtract in the numerator. So here's some examples. Notice that I don't have common denominators right now. I would check this first fraction. Can I factor x squared plus x minus 2? The answer is yes. That's x plus 2, x minus 1. I'm going to cross off the old one. Now I can see that my least common denominator would be x plus 2 times x minus 1. The second fraction needs a factor of x minus 1. For the rest of my problem, I'm going to keep the denominator x plus 2 times x plus 1. And I'm only now worrying about what's happening in my numerator. So in the first fraction, I just have x, and then I'm adding 1 times x minus 1. So that would be plus x, minus 1. Sorry about that. X plus x minus 1. X plus x is 2x minus 1 over x plus 2, x minus 1. None of these are the same factors, so this is my final answer. An additional example, I have 3 over x plus 4 minus x plus 2 over x squared minus 16. Not the same denominator. Go ahead and factor if possible. X squared minus 16 is a difference of perfect squares. I can see they share a factor of x plus 4. This first fraction needs an x minus 4, so I'm going to multiply that on top and bottom. For the rest of my problem, I can keep my denominator, x plus 4 times x minus 4. Only work in my numerator to add and subtract, because I'm going to keep my denominator. This is going to be 3x minus 12. And then I always change this minus sign. I make it plus, and then I distribute my negative. So this is going to be minus x plus 2. That gets me 2x minus 10 over x plus 4, x minus 4. Now, I do notice that on this one, my numerator can factor. 2x minus 10 can be written as 2 times x minus 5. But again, I don't have common factors to cancel, so either of these would be acceptable final answers. Okay, just always make sure that your fraction is simplified if possible. Next example, this one I can see not common denominators and neither one factors, so now I'm going to have to change both. This first fraction needs a factor of x plus 1. The second fraction needs a factor of x plus 3. I now have a common denominator of x plus 3, x plus 1. And I'm going to work up in my numerator. So I'll get 5x plus 5. And then this minus 4 I'm going to actually change to a negative 4. So that when I distribute it, I'll get negative 4x minus 12. Combine like terms in the numerator, I've got x minus 7 over x plus 3, x plus 1. Again, I can easily see that those factors are not the same, so nothing cancels, and this is my final answer. All right, next problem. I can factor So x squared minus 6x plus 9 is x minus 3x minus 3. X squared minus 9 is a difference of perfect squares, so this will be x plus 3, x minus 3. They share an x plus 3 in common, an x minus 3 in common. This first one needs an x plus 3. The second fraction needs another x minus 3. I can keep my denominator, x minus 3, I'm going to write this as squared times x plus 3. And then work in my numerator. Now, for x plus 3 times x plus 3, I'd have to FOIL that out. That's going to be x squared plus 6x plus 9. That's this piece right here, x squared plus 3x plus 3x plus 9. And then I'm going to just FOIL out these two terms quickly before I distribute my negative. That's x squared minus 3x plus 2x minus 6. So x squared minus x minus 6. But then, of course, this is plus a negative, positive, positive. So that's going to be minus x squared plus x plus 6. Combine my like terms. Let's see. X squared minus x squared cancels. I'm going to come up with a 7x plus 15 all over x minus 3 quantity squared times x plus 3. And 7x plus 15 doesn't cancel, so that will be my final answer. Okay, I'll do one more here. I've got x over x squared minus 10x plus 25. That will factor to be x minus 5 times x minus 5. 2x minus 10 will factor to be 2 times x minus 5. They share one factor of x minus 5. The first fraction needs a 2. The second fraction needs an x minus 5. I can keep my denominator of 2 times x minus 5 quantity squared. Work in my numerator so that I get 2x. I'm going to go ahead and FOIL this out. That's x squared minus 9x plus 20. And then, of course, this is subtraction, so change all the signs. This will be minus x squared plus 9x minus 20. Combine my like terms, negative x squared, let's see, plus 11, x minus 20, all over 2 times x minus 5 quantity squared. I could factor out a negative 1 in the numerator, but then I won't have factors of 20 that add to make negative 11, so it won't factor any further, and this could be my final answer. All right, try that homework and see what you can do for adding and subtracting rational expressions.